Hi everyone, this is John the Morgue Owl here, going to do a video response to Neil Degrasse. I found a pretty strange conference or meeting on a stage that Neil Degrasse did with some of his colleagues, so I'm going to roll this and interject as necessary, but this gets pretty bizarre, nonsensical, and kind of deep into the theoretical absurdity of relativity. So let's take a look at it, and I hope you enjoy.
You know, it's been very interesting sitting on the stage and listening to my colleagues. But I am far from experimental physicists, as you can imagine. But this is why experimental.
Which means you're a theorist. Yes.
Something like that.
Yeah, okay.
No, Neil Degrasse Tyson. He's not an experimental physicist, but he's also not a theoretical physicist. He's some third type of, yes, Neil Degrasse. And you've been sitting there with him for, I don't know, probably hours on stage there, and you didn't know whether he was an experimental physicist or a theoretical physicist. Wow.
It's code for I'm a theorist.
I'm a theorist, exactly. But my point is that it is always the case that it is our experimental colleagues that prevent us from forming a religion.
If it wasn't for your experimental colleagues, y'all wouldn't have a job, because why would people pay you to come up with theories without attempting to put them into practice? If you can't make your theoretical premises work in reality, practically, practical uses, then there's no point to what you're doing. And so experimental physicists, I would say, we definitely need them to prevent these crazy GlobeTards from forming a religion. Unfortunately, that's exactly what they've already done, absolutely for sure. But let's get into this a little bit.
Because it is always grounded in what they can measure, as Marcello keeps coming back to. And so although people can express either enthusiasm or dismay about where we are at a given point in time, I think that we need to be a little bit more humble to understand that the process that we engage in is a constant flight from fantasy about what we would want to happen, and we query nature for that, and that query goes through experiment. So although this has probably been very entertaining for my audience here, I think that at the end of the day, we have to keep grounded in it's got to be about things that affect your lives, and those things are measurable things.
Exactly. Totally agree. So we're talking about measurable things, practical things, things that we're going to use every day. So, multi-trillion-mile distant stars made up of theoretical hot atomic fusion as a result of the Big Bang Theory, flying through the theory of space-time, held together by the theory of gravity, and very practical things. And that's in terms of the theoretical astrophysics and such, and the relativity theorists and whatnot. That's where they like to take things, and that's where they've taken us. But if only what this guy just said was true.
So where has this pursuit taken you?
Oh my God.
Where have you landed?
Why would you ask that?
Indeed. Why would he ask that? Is he asking because he already knows what this guy's going to say? Or is he asking because he's afraid this guy's going to say, we figured out the Earth is flat and stationary, so he's getting on the defensive. He's getting ready to drop some mics. He's getting ready to drop some mics and say, this is called gravity.
What is gravity?
You have no idea. Okay, next question. And by the way, this is called gravity.
I gotta say, you're totally blowing my mind right now.
That's what I do. I'm Neil Degrasse Tyson, bitch. I'm asking you that here and now. It's New York City. It's March 7th.
Well, partly it's taken to these very strange images that are behind your head right now. These are pictures of equations. I've been, for the last 15 years, trying to answer the kinds of questions that my colleagues have been raising. And what I've come to understand is that there are these incredible pictures that contain all the information of a set of equations that are related to string theory.
Okay, so we heard what the theoretical physicist just said, that you're seeing pictures of equations on the wall, on the projector, and of course you're seeing Neil Degrasse doing a facepalm as this guy talks. And those pictures of these equations match the equations that he's been using to describe string theory. Now, string theory is an extremely bizarre, non testable, non falsifiable theory of the universe. It's more than we probably want to get into right at the moment, but suffice to say that the mathematics supporting such a theory would be pretty complex, right? And so for anyone to verify what this claim is, he may be 100% accurate that these pictures represent some sort of equations that are also found in string theory, but in terms of, you or I or the average person being able to verify this claim is pretty unlikely, so we're going to have to take his word for it. But we'll go ahead and give him the benefit of the doubt and agree with his claim that those pictures on the walls that sort of look like flying saucers, I guess that's what he's pointing to, represent equations that are found to describe things or used to describe string theory. So let's get back to it.
And it's even more bizarre than that, because when you then try to understand these pictures, you find out that buried in them are computer codes, just like the type that you find in a browser when you go surf the web.
So what he's just said there essentially is that the codes and the algorithms and the equations used to describe string theory that are preserved or found in those pictures that he had on the wall also match the code used for computer programs. And so, we'll get into this a little bit more, but to me, this is evidence that people use similar code in mathematics to describe things like string theory. The same sort of code in mathematics would be used, or could be used, conceivably, to write computer programs. And to me, it's not a connection between string theory and computer programs. It's proof that people use algorithms that are going to be fairly consistent to describe one thing or to be practically used in another. So these algorithms, these equations, these pictures of equations, for whatever that means, are the product of people's brains, our minds trying to describe and rationalize things in mathematical terms, right? And so the fact that the two codes are similar doesn't really jump out at me and scream anything except for people are going to be consistent with code that we know that works, right? So we'll jump back to it. But to me, this is really sort of humorous the way that they react to what he just said, because he clearly said that we're talking about equations that are similar to describe string theory to the codes that are used to program computer programs. So just keep that in mind, because these are man-made equations to describe or will be put into practical use.
And so I'm left with the puzzle of trying to figure out whether I live in the matrix or not.
So he thinks we might live in a matrix because mathematics is consistent from theory to practice. Wow, what a shocker.
Wait, you're blowing my mind at this moment. So are you saying your attempt to understand the fundamental operations of nature leads you to a set of equations that are indistinguishable from the equations that drive search engines and browsers on our computers?
That is correct. So
Wait, I have to just be silent for a minute here.
Goodness gracious, that was pretty rude. I'm pretty sure Neil Degrasse's been running his mouth for the entire conference, and this guy waited to the end to get his point across, and Neil Degrasse tells him to be silent? Oh, lordy.
So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos?
No, you twit. He said that he found computer code that matched computer code, or computer code that matched equations to describe string theory. He didn't say that it was found written in the cosmos. Give me a break, Neil Degrasse. You're grasping at straws.
into the equations that we want to use to describe the cosmos, yes.
Computer code.
Computer code, strings of bits of ones and zeros.
It's not just sort of resembles computer code. You're saying it is computer code.
He's saying that the computer code used to describe it is computer code.
It's not even just is computer code, it's a special kind of computer code that was invented by a scientist named Claude Shannon in the 1940s.
Wait a minute, so you're saying that the matrix that we live in was written in the 1940s by a computer coder? Is that what he's saying? Absolutely not. That is not what he's saying, and yet that's where they're taking it.
That's what we find very, very deeply inside the equations that occur in string theory and in general in systems that we say are supersymmetric.
Okay.
Absolutely no one in there, except perhaps the guy who's telling the story, and he isn't exactly being 100% honest about this. He's allowing them to sort of take this bait that somehow there is computer code in the fabric of the universe, when in fact we're talking about computer code that was written in the 1940s to describe the universe in a possible string theory. So of course that's going to be made out of ones and zeros, and if they make some sort of a picture out of that, and it matches the ones and zeros that are used to make software programs, well, that really is not a surprise, because we're talking about code that people are using for different sort of applications. I mean, come on.
Time to go home, I think. Where are we going to go? So are you saying we are all just, there's some entity that programmed the universe?
Yes, Neil Degrasse, that's exactly what he's saying. He's saying that the universe was invented in a lab by a computer scientist in the 1940s. Yes, that's exactly what he's saying, of course.
And we're just expressions of their code?
Well, I didn't say that.
No, he didn't say that. But unfortunately, the damage has already been done. This is like one of those times Neil Degrasse is playing the lawyer who spurts out something totally inappropriate that makes the defendant appear guilty, right? Tyson proved that the universe was developed in a computer program by a coder in the 1940s. Or whenever. But the fact is that isn't the claim at all. And yet they're sort of busting out pageantry and showmanship in order to sort of parade this idea around as if it is a viable, cogent theory, when it absolutely is not. The Earth is a stationary plane. It isn't a string theory, or a heliocentric theory, or an acentric theory, or any theory. It is a stationary plane.
Some of those
Like the Matrix? That's what you said.
Some of those codes are showing on the screen behind you right now. They don't look like codes, but these pictures, which we call adinkras, are graphical representations of sets of equations that are based on code.
Graphical representations of equations based on codes. Just keep that in mind.
So this is, in fact, to answer your question more directly, I have in my life come to a very strange place because I never expected that the movie The Matrix might be an accurate representation of the place in which I live.
Oh my gosh, you guys. Neil Degrasse said that we live in the Matrix, and there was this scientist guy, and he proved it using math. I'm gonna go find Neo, and I'm gonna go get on the Nebuchadnezzar and eat oatmeal slop, and go live underground. Zion, Neil Degrasse Tyson, and Lawrence Fishburne, and Keanu Reeves, and that chick who played Trinity. Not the dude that ate the steak with Agent Smith. Don't want him around there.
Ignorance is bliss. Jim, may I give you an argument that we don't live in the Matrix?
Please. Yeah.
Very simple argument.
Give me one now, quick.
A very simple argument. There's a property that the real world right down here has that no mathematical equation has, that no solution of an equation has, that no abstract object has.
I would bet that he's going to say physical form. You know, matter properties. So in other words, you're never going to change a hypothetical equation or an algorithm or a code into a physical object. So in other words, theoretical code doesn't have physical properties. That would be my best guess as to what this guy's going to say, but, well, let's just see.
Here in the real world, it is always some moment, which is one of a series of passing moments. And a mathematical equation doesn't have a flow of time in it. It just is.
A mathematical equation doesn't have flow of time in it? Okay. So what about those old high school and middle school math problems where they're like,
If Jimmy gets on a bus and the bus accelerates at 50 miles per hour per second for 30 seconds and then maintains.
what about those problems? Doesn't that have the flow of time in it, or am I missing something? Wouldn't you say the fundamental difference between theoretical equations and real things would be the fact that theoretical equations are not physical objects, as opposed to they don't have the flow of time in them, they just are? Where do these people, like, who pays these people to sit up there on stage and talk? Wow.
And a mathematical equation doesn't have a flow of time in it. It just is.
No,
and this means...
But Lee...
Wait, let him finish. Wait, I need him here and now.
This means that, to me, that the ancient metaphysical fantasy that we quote are just mathematics cannot be true, because in a world that was just mathematics, there would be no moment of time.
What about physical properties? Certainly you can't be saying that mathematics, hypothetical placeholders, can have physical properties, right? I mean, come on, give me a break, man. The big difference here is physical properties. Time is a construct of the human brain. The alphabet can make words. You can say them. You can plan things out mathematically and measure them. Build things based on mathematical plans. But certainly anyone would agree that mathematics has no physical properties. It's merely hypothetical placeholders.
Why isn't
Which
there
is- Lee,
math as a
Lee,
function
Lee,
of time?
I'm sorry,
We
Lee.
solve
They're
those.
just-
These are differential equations.
Oh, look at the mathematicians go and confuse everyone with their mathematical vernacular that nobody understands really but them, and they really don't understand it but they purport to. Look at them go. Look at the math magicians go. Ain't it sweet? Okay, and now finally the guy that was originally telling this story is going to burst some bubbles.
But,
No, Lee,
then you lay the solution out. X is a... Yeah.
You're mistaking... You keep using the word is, and I'm talking about the word describe.
It depends upon what the meaning of the word is. Yes.
You see, the whole...
described is fine, but
No,
then,
but
then we're
let
not
me
in the
let me
matrix.
finish, please, since
Yeah.
we started with my discussion. The point is that it's fun to talk about some deep metaphysical essence that sits behind physics, but for some of us, it's about trying to find the most accurate way to describe where we...
I got a news flash for all y'all. The Earth isn't a spinning sphere. Why don't you measure that?
And so my statement is that in the description of our universe, that is a supersymmetrical universe, which we were going to test in the LHC. If you believe that description, I can show you the presence of these codes. That's my statement.
So while Neil deGrasse Tyson is up playing musical chairs, being a camera hog, you're saying that you're going to show us man-made code that seems to jive with other man-made code to describe things and to put into practical use. Wow. And you said if you believe this description, then you can show it to him. What if he doesn't believe your description?
If you believe that description, I can show you the presence of these codes. That's my statement.
That's beautiful, and that's fine, and I admire that. Seriously, that's fine. That's another beautiful piece of mathematics that may be explanatory or descriptive of physics, but that all I'm objecting to is that doesn't mean that we live in the mathematics. That means the mathematics is just descriptive of an aspect of the universe, and
Well, that's a
we're
good
not
point.
in
Let
the
me follow
matrix.
that one up. Jim, just because, who was it? Eugene Brigner, who commented on the unreasonable effectiveness of mathematics that we just invent in our head, yet the universe follows, can be described mathematically.
No, the universe does not adhere to our mathematical descriptions. Our mathematical descriptions are constructed around observable reality.
Mathematics is the language of the universe.
Mathematics is a universal language amongst humans, people. The universe is not going to conform or bend to our mathematical formulas. Mathematical formulas will only be used to describe things that already exist, or you can, use mathematical formulas for plans and things like that, but mathematics is never going to have physical properties, nor is it going to dictate the exterior, quote unquote, so called infinite universe that doesn't exist.
Brian, math math is your tool. So should we be amazed or depressed by what Jim tells us here?
I can't really comment on what Jim says. I find myself in the unusual position of feeling rather conservative on a panel when usually I'm sort of at the outside.
And by the way, the pictures Jim showed all look like spirograph images
I saw them.
from your kids'
I don't
thing.
know enough about them to comment, but there is an interesting question, the one that you raise, about whether math is descriptive of the universe, or we are the math, or what's the role of math? Do you discover it? Is it invented? I mean, I had a conversation, and I think you may have been involved in it, if I'm not mistaken. The question was, is math the right way of going about trying to find deep physical law? And I said, look, I can imagine one day we'll encounter aliens, and they'll say to us, okay, show us what you've got.
Oh, yeah, being very conservative there. I agree. Yeah, one day you might run into aliens. How very conservative of you.
To describe the universe, we break out our mathematics, and they look at it and they say, oh, Matt, we used to do that. Ultimately, a dead end, and then they show us what they have found.
You're insinuating that your colleagues' life work and theory is garbage. That's what you're insinuating.
Now, the problem with that is I don't actually even know what I would fill in regarding what they would show us, because to me, mathematics is really the language of pattern. It's self-consistent ways of embodying pattern, and that's ultimately what we do. We're pattern recognition machines. We try to codify the patterns we see in the world around us in math, and in that way we try to describe the universe around us. Does that mean we are the mathematics?
No, we are absolutely not made up of the mathematics whatsoever. I agree. We can describe things mathematically, but things are not built by mathematics. At least not naturally, right? Of course, people can build things using mathematical plans, but equations are simply not going to manifest anything in the physical realm.
I don't know. It becomes really hard to really know exactly what that means, but we have found that math, so far, is a potent tool for making predictions that we can test and confirm, and that's why I follow this particular trajectory.
Brian, we're going to have to very shortly go to questions from the audience, but I want to come back at you with a couple of questions that are sort of purposefully blunt. Okay?
Yeah.
So you guys have been at this string theory for running on 2 decades now, and Einstein, working alone, went from special relativity to general relativity in 10 years, working alone.
And by working alone, you mean stealing other people's ideas.
And it was a brilliant piece of work, and there was an experimental verification 4 years after he came up with the idea.
Okay, so looking here at the theory of relativity, Wikipedia is the source on this. I'm going to go ahead and read through this and branch off as we go, because Neil Degrasse's claim, he's basically poking fun at his colleagues, saying they've had decades, essentially, to work on string theory, and they can't prove it. They're essentially grasping at straws and not getting anywhere. Yet his claim to sort of poo-poo on them is, nothing that we haven't already heard. It's that Einstein came up with his theories of relativity, which he actually stole the ideas for. But, Einstein came up with these on his own, and within 4 years he had alleged experimental evidence for it. Now, one thing about Einstein is we really can't trust him, to be very honest. For one thing, he was a patent clerk, and it really appears as if he was stealing people's ideas. He wasn't this genius, mad scientist that he was painted as in the media. He was more or less a slacker, according to his teachers. He was sort of a buffoon. He was a high school dropout. It took him a few times to get into higher education. Took him a few tries. And all of his professors and the people that knew him would say that he wasn't a genius. He apparently beat his wife, and He lied about things in order to make himself seem more credible. Now, one of the things that I also believe about Einstein and his predictions is that he already knew certain outcomes that other people may or may not have known. So, for example, in terms of gravitational lensing around the sun and moon during an eclipse, um, Einstein predicted that the stars, which were normally behind the sun, would be visible during an eclipse due to gravitational lensing, and it was observed exactly as he predicted it. Now, could this be because he knew and had already observed or was aware of observations that this did occur during eclipses? And that would make his theory seem to hold water if he could predict something with it, even though he already knew that the prediction would come true. So it isn't a prediction, it's a self-fulfilling prophecy in order to, lend credence to Einstein's theories. And it really appears that that's the sort of thing that we're up against. So I'm going to read a little bit about the theory of relativity. There's two of them. There's general relativity and special relativity. Then you have things like the Lorentz factor, time dilation, and other things. So let's get into it. This article is about the scientific concept. For philosophical or ontological theories about relativity, see relativism. For the silent film, see the Einstein theory of relativity. The theory of relativity usually encompasses two interrelated theories by Albert Einstein, special relativity and general relativity. Special relativity applies to elementary particles and their interactions,
Elementary, my dear particle, elementary.
describing all their physical phenomenon except gravity. General relativity explains the law of gravitation and its relation to other forces of nature. It applies to the cosmological and astrophysical realm, including astronomy. The theory transformed theoretical physics and astronomy during the 20th century, superseding a 200-year-old theory of mechanics, created primarily by Isaac Newton. It introduced concepts including space-time as a unified entity of space and time, relativity of simultaneity, kinematic and gravitational time dilation, and length contraction. Now, I'm not going to touch on all these, that's sort of end quote right there, but space-time is a theory that space and time are meshed together in the fabric of the vacuum of space.
What's so humorous to me is the fact that people like Neil Degrasse will humor theories about living in the Matrix, but he will absolutely not measure the curvature of the Earth to find that it doesn't exist.
Gravitational time dilation is another thing that we're going to touch on here, but let's continue with the quote. In the field of physics, relativity improved the science of elementary particles and their fundamental interactions, along with ushering in the nuclear age. End quote. Now, the nuclear age is a myth. Nuclear bombs don't exist. Hot atomic fusion, as purported, that's going on in the stars, does not exist except in the realm of theory.
Nuclear energy is a misnomer. It is actually very much the same as steam power, like an old steam engine. However, they're not burning coal or they're not burning any sort of fuel. They encase a radioactive isotope in a small area so as to generate heat to boil the water. So, nuclear power is a misnomer. Nuclear bombs don't exist. And of course, hot atomic fusion is theoretical.
Furthermore, gravity, as a warping of theoretical space-time, only exists in theory. Back to the quote, with relativity, cosmology and astrophysics predicted extraordinary astronomical phenomena such as neutron stars, black holes, and gravitational waves. Now, isn't it rather convenient that LIGO found the first evidence for black holes and gravity waves and binary black holes merging into a single singularity? I mean, isn't that rather convenient that scientists have spent probably hundreds of billions of dollars trying to prove these theories of Einstein that do not exist? And so it's very obvious that they are faking this data And whether all of the scientists are in on this or not is irrelevant. It only takes one person or a handful of people at the top of these places like LIGO and NASA to fool everyone by letting them do their jobs, rewarding them for a job well done, and giving them results in the form of computer data, whether it's telemetry or readings from LIGO or readings from the Large Hadron Collider. For all we know, and what it really appears to be, is that the scientists on the back end of those computer data monitors are getting bogus, fabricated data that is created to look as if it is real telemetry or particle accelerator data when it is not. So, back to the quote, skipping ahead to the section Development and Acceptance. Albert Einstein published the theory of special relativity in 1905, building on many theoretical results and empirical findings obtained by Albert A. Michelson, Hendrik Lorentz, and Henri Poincaré, and others. Max Planck, Hermann Minkowski, and others did subsequent work. Einstein developed general relativity between 1907 and 1915, with contributions by many others after 1915. The final form of general relativity was published in 1916. The term theory of relativity was based on the expression relative theory, used in 1906 by Planck, who emphasized how the theory uses the principle of relativity. Well, no. In the discussion section of the same paper, Alfred Butcherer used for the first time the expression theory of relativity. By the 1920s, the physics community understood and accepted special relativity. It rapidly became a significant and necessary tool for theorists and experimentalists in the new fields of atomic physics, nuclear physics, and quantum mechanics. By comparison, general relativity did not appear to be as useful beyond making minor corrections to predictions of Newtonian gravitation theory. It seemed to offer little potential for experimental test, as most of its assertions were on an astronomical scale. Its mathematics of general relativity seemed difficult and fully understandable only by a small number of people. Around 1960, general relativity became central to physics and astronomy. New mathematical techniques to apply to general relativity streamlined calculations and made its concepts more easily visualized. Astronomical phenomena were discovered, such as quasars in 1963, the 3 Kelvin microwave background radiation 1965, pulsars 1967, and the first black hole candidates in 1981. The theory explained their attributes, and measurement of them further confirmed the theory. End quote. So this is that sort of slippery slope where if you already know what an end result's going to be, whether it's something fabricated or a natural observation, and nobody else is aware of it, and you bust out a theory that explains certain things or predicts certain things that you already know are going to happen but nobody else does, then it really does sort of falsely lend credence to your theory. So, for example, there are legends of Mayan royalty knowing full well when an eclipse was going to take place, yet none of his subjects would have known because, eclipses occur in predictable cycles, in patterns. And so, by saying that this royalty controls the sun and moon in terms of eclipses or solar eclipses, then that gives him power over people because they believe there is some sort of divinity or at least correctness to their theory or to their religion. And I see this as very much the same thing in a slightly different way, but indeed Einstein even used eclipses in some of his proofs. Another one would be clocks ticking more slowly if you're traveling at a high velocity above the face of the Earth. That may or may not actually be true. I've never tested it, but if it is, we can certainly say that it's has nothing to do with gravity or the theory of relativity. It's probably more like an electromagnetic phenomenon, because again, gravity doesn't exist. So let's dive in a little bit deeper into special relativity. Special relativity is a theory of the structure of space-time. It was introduced in Einstein's 1905 paper, quote, on the electrodynamics of moving bodies, end quote. For the contributions of many other physicists, see History of Special Relativity.
Special relativity, do you think they make this stuff complicated enough? I mean, you get to reading all of this, and it's just so much posturing and big words and jargon for the sake of sounding complex and scientific. So, one, the laws of physics are the same for all observers in uniform motion relative to one another. That is called the principle of relativity. The speed of light in a vacuum is the same for all observers, regardless of their relative motion or the motion of the light source. So we're talking about objects in motion and light sources in motion. The resultant theory copes with experiment better than classical mechanics. For instance, postulate 2 explains the results of Michelson-Morley experiment. Moreover, the theory has many surprising and counterintuitive consequences. Now, I will just mention that the Michelson-Morley experiment is really excellent proof that the ether exists, space-time doesn't exist, and in fact the world is stationary, not spinning, not flying through space, not doing any of that, yet relativity does away with the ether, replaces it with space-time. So, back to the quote, some of these are, an example, relativity of simultaneity. Two events simultaneous for one observer may not be simultaneous for another observer if the observers are in relative motion. Time dilation. Moving clocks are measured to tick more slowly than an observer's stationary clock. So I guess what I'm saying is if that's true, and Einstein and his entourage knew about clocks ticking more slowly in motion, then they could have potentially developed a theory that had that known fact as an experimental proof or a supporting proof. Relativistic mass, length contraction. Objects are measured to be shortened in the direction that they are moving with respect to the observer. Mass energy equivalence, E equals mc squared. Energy and mass are equivalent and transmutable. Maximum speed is finite. No physical object, message, or field line can travel faster than the speed of light in a vacuum. The effect of gravity can only travel through space at the speed of light, not faster or instantaneously. The defining feature of special relativity is the replacement of Galilean transformations of classical mechanics by the Lorentz transformations. See Maxwell's equations of electromagnetism. Right, we're not going to do that right now. So, general relativity. General relativity is the theory of gravitation developed by Einstein in the years of 1907 through 1915. The development of general relativity began with the equivalence principle, under which the states of acceleration, motion, and being at rest in a gravitational field, for example when standing on the surface of the Earth, are physically identical. The upshot of this is that free fall is an inertial motion. An object in free fall is falling because that is how objects move when there is no force being exerted on them, instead of this being due to the force of gravity, as is the case, allegedly, in classical mechanics. This is incompatible with classical mechanics and special relativity because in those theories, inertially moving objects cannot accelerate with respect to each other, but objects in free fall do so. To resolve this difficulty, Einstein first proposed that space-time is curved. In 1915, he devised the Einstein field equations, which relate to the curvature of space-time with the mass, energy, and any momentum within it. Ending the quote real quick, what is so preposterous about this is the fact that Einstein was somehow able to measure or theorize the curvature of space-time, yet all of these people were unable to measure the curvature of the Earth, which would be the cause of the curved space-time in our area. Since there is no curvature, the entire theory of curved space-time goes right out the window. Some of the consequences of general relativity are, allegedly, clocks run slower in deeper gravitational wells. This is called gravitational time dilation. So, gravitational time dilation. Ending the quote real quick, what really baffles me about this is the Earth's orbit is allegedly not a perfect circle around the sun. They claim that during the northern winter, the Earth is closer to the sun, and during the northern summer, the Earth is further from the sun in its orbit. And so, wouldn't you expect that the sun, since, it would necessarily be an extremely gravitationally rich object in the theory, then shouldn't our proximity to the sun change how time flows for us here? It's just a question, but you would expect the gravitational pull of the sun, or the gravitational properties of the sun, to sometimes affect us here on Earth. But apparently it does not. And that's sort of a problem. I've been aware of this as a, lifelong globehead for many years, that if you are traveling much, much faster than a stationary observer, then your clock is going to run slower than the stationary observer. And I found a thread on physicsforums.com. I will be putting a link in the description. So this question on physics forums was posted July 1st of 2003. So, has time dilation ever been proven experimentally? And we're going to read through some of these responses because I just thought this was really interesting when I stumbled on it. Antiproton says it has. Indeed, time dilation has been proven according to Antiproton on physicsforums.com. It has. There's a great video we watching in one of my first physics classes. They have two atomic clocks, cesium, one on Earth and one on a very high altitude plane traveling very fast. Once the plane landed, they compared the clocks and found a distinct difference in the time. I forget how much time, but it was there. Well, here comes PMB saying, well, no theory can ever be proven. However, it's been confirmed quite adequately. By that, as in purchase that, I mean that we use a theory to make a prediction. We then do an experiment. Are the results of the experiment consistent with the prediction? If so, then we are more comfortable with the prediction. For instance, the depth of penetration of muons into our atmosphere is consistent with relativity. Muons decay and have a particular half-life. We can use that to see that this half-life changes with speed. It does. Therefore, their results are consistent with the theory. And this would be exactly like the Mayan peasant, in my example earlier, saying that the king is obviously God incarnate because he made the sun eclipse. So, what the theory is that time dilation is exclusive to gravitational fields and has to do with your velocity relative to the Earth, I would suppose. Because if you're stationary with the Earth and a clock is stationary with you, that clock is going to run slower than somebody that's flying at a high altitude according to this theory. Now, to say that this is exclusive to gravitational fields, or whatever they claim that it is caused by, is a logical fallacy. It could be caused by any number of things, or it could be faked to support the theory. So, continuing on with the responses to the question, and again, the question was, has time dilation ever been proven experimentally? Troot comes and says, it's rather well tested. Physics Rocks 88 comes and says, what? Who in the hell on earth are you? No theory could ever be proven. Could a more stupid statement come from animal's mouth? And Troot says, you need to calm down. Such displays of hostility will generally not be tolerated here. You cannot ever prove a physical theory, because to do so would require that you demonstrate that it works in every possible experiment. And there are an infinite number of possible experiments. No matter how many experiments you do, which all agree with your theory, there will be more experiments left to do. And you cannot be sure they won't disagree with your theory. The best you can hope to do in science is to declare that your own theory is proven within the domain of the experiments you've subjected it to. You cannot say anything about its applicability to experiments that have not yet been performed. Now,
I understand what Trout here is saying. You cannot ever prove a physical theory if we're talking about astrophysics or quantum physics. If we're talking about the Earth being a spinning sphere or a stationary plane, on the other hand, a stationary plane will definitely agree with any infinite number of experiments you throw at it. Doesn't matter. The Earth will always be shown to be a stationary plane. And so that's where I disagree that you cannot prove a physical theory. We've certainly debunked the notion of a spinning spherical Earth, and all of the experiments that have been done to detect curvature and motion of the Earth clearly align with the fact that the Earth is not a sphere, nor is it in motion. Theoretical things that will never be visible or demonstrated. We're talking about the very physical properties of the Earth that can indeed be measured. Dave says you can only prove theories wrong, not right. PMB says, yep, it's true. It's always conceivable that someone may make an observation which contradicts the theory. So you sort of get the point here. We're going to read this one from Thomas. The slowdown of the atomic clock in the airplane experiment could well be explained by other than relativistic effects, for instance by the Lorentz force in the Earth's magnetic field. So let's get back to the wiki sort of overview of the theories of relativity. Skipping down to experimental evidence, Einstein stated that the theory of relativity belongs to a class of principal theories. As such, it employs an analytic method, which means that the elements of this theory are not based on hypothesis, but on empirical discovery, and I would say that that is hogwash. By observing natural processes, we understand their general characteristics, devise mathematical models to describe what we observed, and by analytical means we deduce the necessary conditions that have to be satisfied. Measurement of separate events must satisfy these conditions and match the theory's conclusions. Tests of special relativity. Relativity is a falsifiable theory, so they claim here, although it really is not. It makes predictions that can be tested by experiment. And I would say that the experiments are probably good and well thought out. However, the interpretations of the data is flawed. Back to the quote, in this case of special relativity, these include the principle of relativity, the constancy of the speed of light, and time dilation. And we already know that time dilation has never been proven. We've seen some experimental data that seems to align with it, but they act as if this is, something that you can hang your hat on in terms of time dilation, and it really truly is not, and we'll see why here in a little while. Back to the quote, these predictions of special relativity have been confirmed in numerous tests, allegedly, since Einstein published his paper in 1905. But 3 experiments conducted between 1881 and 1938 were critical to its validation. These are the Michelson-Morley experiment, the Kennedy-Thorndike experiment, and the Ives-Stilwell experiment. Now, this is a bit misleading here because they use the term these experiments were critical to relativity's validation. Now, one reading this might think that these experiments were critical to its validation in terms of a necessary component. Critical. These experiments were a necessary component to relativity's validation. But that's not what it means. It means critical in the sense of criticizing or disagreeing with its validation. And in truth, in terms of at least the Michelson-Morley experiment, disproving the idea of relativity in space-time and showing that there is indeed an ether or a medium through which starlight and celestial light travels through, and in fact that the Earth is stationary. So that is very slick the way that they phrase that, because the word critical can be defined 2 ways, right? It can either be critical of something in terms of disagreeing with it and criticizing it, or it could be critical to. And that's really what the phrase they should have used was critical of, not critical to. And so that is a misleading phrase. Maybe we should write wiki. Einstein derived the Lorentz transformations from first principles in 1905, but these three experiments allow the transformations to be induced from experimental evidence. So, we're looking at the Lorentz factor here. The Lorentz factor, or the gamma factor, not to be confused with gamma function, the Lorentz factor, or Lorentz term, is the factor by which time, length, and relativistic mass change for an object while that object is moving. Now, it appears that Lorentz had introduced the idea of time dilation as early as 1892 or as late as 1895, won a Nobel Prize right at the turn of the century for his work, and a lot of people credit Einstein with even the idea of time dilation. And really, his theory of relativity hinges upon time dilation as a proof or an experimental support for that theory of relativity. And so it is extremely obvious and very that it was disingenuous, or it's extremely obvious. It is extremely obvious that Einstein was being disingenuous, even with the idea of time dilation, taking credit for Lorentz's work. The expression appears in several equations in special relativity, and it arises in derivations of the Lorentz transformations. The name originates from its earlier appearance in Lorentzian electrodynamics, named after the Dutch physicist Hendrik Lorentz. Due to its ubiquity, it's generally denoted with the symbol Y. What we have here is really quite obviously Einstein stepping on the backs and taking credit for the ideas and research of those who came before him, and really wrecking any evidence that went against the globe Earth in an infinite space narrative. That's what Einstein achieved. We'll get back to the clip, but I just thought this was hilarious. The modern applications of the theory of relativity, quoting again from Wiki, which is we've already proven is an extremely questionable source, but we'll go ahead and do it. Far from being simply of theoretical interest, relativistic effects are important practical engineering concerns. Let's hear these practical engineering concerns. Of course, satellite-based measurement needs to take into account relativistic effects, as each satellite is in motion relative to an earthbound user and is thus in a different frame of reference under the theory of relativity. Now, end quote. I just would say that wouldn't the more practical engineering concern have to do with general aviation as opposed to satellites? Now, I'm no pilot, and perhaps I'll ask this to Bob on Globebusters on Sunday, but, do pilots have to have special watches that are synchronized to the speed of the plane relative to the Earth? Or, that isn't taken into account by pilots, shouldn't it be?
Copy that, ground. We'll be landing at about noon. Understood, Eagle. That noon Eastern or Pacific? That would be noon Eastern. Did you set your clock for time dilation? Over. No, I forgot to set my clock for time dilation. Over.
Now, another one of these practical engineering concerns is, of course, global positioning systems such as GPS or GLONASS. And of course, we know that GPS is ground-based positioning systems using towers, possibly weather balloons, and has nothing to do with satellites. It's triangulation technology that the military was doing back in the 40s and the 50s, simply radio frequency triangulation. So the idea of satellites up there, tens of thousands of miles away, beaming back data through the ionosphere and the magnetosphere and all the layers of troposphere and everything, yeah, that makes absolutely no sense whatsoever. But of course, it's extremely expensive to launch satellites into space, so they have to steal $20 billion a year just in tax money, not to mention all of the bills we have to pay for GPS and cell phones and entertainment in the home, and all of that stuff is they nickel and dime you with stuff that Tesla wanted to roll out freely. And of course, we have these practical engineering concerns of where the theory of relativity and time dilation comes into play.
It's just ridiculous that they don't even mention aviation here. So I will definitely ask a pilot about that.
Here you have legions of string theorists working 2 decades, and you're sort of not there yet. Is there just not enough of you? Are you chasing a ghost?
No, what happened was is Einstein was extremely wily, or at least his team of people were, and so modern scientists don't have eclipses that they can turn to and say that it is string theory that causes the movement or the apparent movement of stars that are behind the sun. See, if nobody had noticed that up until now, scientists could have observed this phenomenon of stars that should technically be behind the sun during an eclipse being visible. They could have said it was string theory as opposed to gravitational lensing. But unfortunately, Einstein got to eclipses first, as well as time dilation first, in order to pseudo prove his theory of relativity.
Or are the collection of you just too stupid to figure this out?
I mean, I think it's pretty clear. It's the latter. You know.
I would have to say that I 100% concur.
Well, look, you know, Einstein was a singular genius, and making comparisons with him, I think, is perhaps not that representative.
Einstein was a genius in terms of a scam artist.
But putting that to the side, look, the questions that Einstein was trying to resolve, however deep they were still within a realm that was experimentally accessible.
Experimentally accessible? So E equals mc squared, energy, is created by accelerating mass to the speed of light squared. That is never going to be experimentally provable, demonstrable in the slightest.
Within a couple of years, a couple decades at most. We are ambitious, and we are trying to make a big leap to try to understand the universe on fantastically small scales and fantastically high energies. Why are we so ambitious? Because we have been so successful theoretically to date that the open questions in this line of research are the ones that we're now focused upon.
Stealing Nikola Tesla's designs for infrastructure, tricking people into thinking it's satellites, and instead of giving them the technology benefits for free, charging them out the ass on a monthly basis for everything. That is not exactly...
Because we have been so successful theoretically to date.
That is using Einstein's theories in order to entrap and enslave people and deceive them into thinking that GPS and satellites are connected somehow. Satellites actually do not exist. They're unnecessary and impossible.
They're much harder to test, and therefore we don't have the guidance of experiment to nudge us this way or that as much as in the past. Now, if we could solve these questions, I think we'd be answering some of the deep mysteries of the ages. Do you say, well, you haven't cracked it in 20 years, so it's time to give up?
Why don't you just do what science normally does and lie, make something up, and say that it's been proven? That would be following suit with Einstein.
No, I think you say, if progress stalls, then you go and look at other directions.
All y'all need to be looking in a completely another direction than you're looking. String theory is so preposterous, right along with relativity and gravity and space-time and Big Bangism and heliocentrism. All of this stuff is theoretical nonsense when you do indeed realize that the Earth is a stationary plane. There's no spinning, there's no axial rotation, there's no orbital motion. All of that stuff has been falsified and in fact does not exist. And so in order to have progress in any theoretical physics, I submit that you would need to be a flat earther and understand the truth first before going out into theoretical premises based on conjecture, hypothesis, lies, and misunderstandings, as do globeheads.
But as long as progress is carrying forward, and it is, you keep going and try to figure things out. You can't place a time limit on it.
So we're supposed to let you idiotic theoreticists play in the sandbox forever as you waste tens of billions of dollars per year trying to prove string theory, and to what end?
I think your pace of progress is sufficiently slow that it has led to these other ideas exhibited on this panel.
Slow as in completely stationary, as in not progressing at all? grasping at straws, saying that the universe is made up of code that is similar to computer programs. Or, no, I'm sorry, the universe is described by code that is similar to code used for computer programs. Goodness.
Well, I don't
Because
know
you're
what
slow,
you,
that
you
Jim
know,
is finding
I-
that we live in a matrix, and
sorry
that
to-
and that
you know,
Marcelo
I get-
is
I get worried
questioning
about
the whole
some of-
idea of a unified theory.
Okay, so that pretty much concludes what I wanted to cover in this video. This interview, or whatever the heck this is, this meeting on stage, I'm not sure what exactly you would call that. But, you know, it's just so idiotic of these scientists really going off onto these tangents in terms of really quite bizarre theories that have nothing to do whatsoever with reality. So with that, if you'd like to support this channel, you can do so direct to PayPal to the link here. It's www.paypal.me/themorgile1, or direct through PayPal to johnelance@gmail.com. Thanks so much for watching. Spread the word, spread the world, and peace.